Our third theme for this review is on probability, and you guys have at least hopefully looked at each of the questions, realizing that some of the numbers in the tables are very small, and I apologize for that in advance. But let's go ahead and jump in here. The first topic that we're going to look at deals with relative frequency. Things to review, do we remember the addition rule? Do we remember the multiplication rule? Do we know what it means to be independent? I'm just going to put that way at the top. There we go. Conditional probability, tree diagrams, all those things that you see mentioned here. And we'll look at basically a lot of formulas, right? And how to use those formulas and when to use them, etc. So if we look at this particular question, I'm just going to give you the answers. And if you have a question or you want to go over it, let me know, and we will. But the answer to this one is B. How'd we do? Okay, Sammy, look at your answers, babe. This is a binomial situation. Okay, we have to remember what it means to be binomial. It's binomial because there are 4 things that make something binomial. Maybe if you would write these notes down in case you weren't sure. But we should check to see if it is binomial, because binomials, if you look at your formula sheet, have their own mean and standard deviation, right? The mean is NP, and the standard deviation is the square root of NPQ. So, okay. So if it's binomial, we'll double check to make sure that if it is, we can use those formulas. And so the first type of binomial is, are the events independent? Okay, so write this down if you don't remember it. Okay. So let's look here. Are they independent situations? Or is each trial independent? In other words, to say it that way. Yes or no here? What are the trials? The corals themselves. If one is poisonous, it doesn't mean another one will be, right? Okay. The probability is the same for each event. Is that true here? Isn't it 73%? In Australia, it says 73% are poisonous, right? Okay. The third one is that there are 2 outcomes. We call that the success failure, right? They're either poisonous or they're not poisonous. So there are 2 outcomes here. And then the fourth one is that there are a set number of trials. Okay? We have an N. So do we have a set number of trials in this case? We have 25, right? Okay, so we can use our formulas here, maybe. There we go. And our formulas are that the mean is just N times P, and that the standard deviation is the square root of, I always say NPQ, but I think that your formula sheet says 1 minus P because it doesn't specify Q. So N times P is the mean, so that would be, what is that, 25 times 75%? Is that right? Double check me. 73%, thank you. I don't have it in front of me. And hopefully you get 18.25 when you do that. And then the standard deviation is just simply the square root of N, P, and then 1 minus P. And hopefully when you do that, you get 2.22. So because it's a binomial situation, we could use this to find our mean and standard deviation.
Whatever, like, asking for the variance? Or it's not
it could, but you would just square the number.
So just the NP?
It would, yeah. Mm-hmm. It would be NP.
Yay.
All right? Good? Next question. This is totally in the way. Good. All right, next question. We're talking about the poll in 1992. It says that 15% of the public has responded to a telephone call-in poll. And by the way, what kind of bias does that have? Voluntary response bias, because you are making them volunteer to call in, right? In a random group of 5 people, what is the probability that exactly 2 have responded to a call-in poll? I see a lot of keywords in this problem that clue me into what to do. Give me one of the keywords that you see.
15%.
Okay, I have a probability. That doesn't clue me specifically into what to do, but it is important information. Sean?
Exactly.
I see exactly is a big keyword. Give me something else. Important information, right? Maybe not tell me what to do. What does the exactly to, Sean, what does that clue me into to what I should do?
What?
Binom PDF. Okay? So let's check to make sure it's a binomial situation again. Let's go through them. Do I have independent trials? One person calling in independent of another person calling in. Do I have a set number of trials? Do I have a P, a consistent P? And then what was the last one? Success, failure. They either call in or they don't. Right? Question. Yep, that's exactly right. Okay, so it's binom. It's a binom PDF. If you want to do the calculator, it's a multiple choice question. We don't have to worry about our calculator speak, so to speak. Okay. So what is the order that goes in the binom PDF, if you remember? The calculator asks you for it, by the way. So if we can do it that way. Okay. Right, so it's NPX, I think, right? So if we go ahead and do binom PDF here, we have the set number of trials, which was 5. Our probability was 15%, and the x value was exactly 2. So we have 5.152, and we should have gotten 0.14 or 0.138. Now, just to kind of refresh our memory, for those of us who remember the formula, you do have a binomial formula on your formula sheet as well. It is it's right there in the middle, n choose k. So it's going to be 5 choose 2. And then we have 0.15 to the 2 power, and then 1 minus 0.15 to the 3 power. Do you want to go over how to plug that into the calculator with the choose and all that? Do you remember? Let's just remind ourselves in case we need it, okay? So how do I find 5 choose 2? 5, math PRB, choose 2. That's 10. We have 5 things. How many ways can we combine groups of 2? And then we're going to multiply that times 0.15 to the 2nd power. And multiply that times 0.85 to the 3rd power. Okay, we should still get the same number. Doesn't matter whether you use the formula or whether you use the functionality of the calculator.
I keep forgetting that the one over the other is the
Choose.
Yeah.
It's not a fraction.
I like the
PD. Right. Yeah, me too. Notationally, it's just there's different ways to mean the same thing. Right. Let's go on to the next question. Okay. In this particular one, we have another binomial situation, but read this one. A, we need to identify that it is binomial, so you want to do your check for that. Okay. But this is a little bit differently. Why is this one different? What's the key word? Rather than exactly, Sean, what does it have instead? At least. At least one means we're no longer in the PDF situation. We're in the cumulative binom CDF. We should identify our N, our P, and our K. Your formula sheet uses K rather than X. Your calculator uses X. Wish they could all just be consistent. So what is at least 1? 1 minus the probability of none, right? So we're going to use our cumulative, we're going to use our, the complement, just use the complement to answer the question. So 1 minus, and honestly, since it's just the 0 that we're calculating, I could use PDF or CDF, it doesn't matter. We're just finding the probability of 0, okay? It won't matter. I'm going to use CDF, but again, it doesn't matter here. And what is the order that we go in the other direction here? How many total things do we have? 100. In a group of 100. Okay, so that would be 100. And then we have a probability. It's written a little oddly here. But 25 out of 100,000. So I'm just going to write that as a fraction. And then we have how many? At least one. So we're going to put what number here? 0, because we're looking for we're subtracting that from 1 here. Okay. Daniel is just kind of coming back a little bit, sort of slowly. Do you question, Judith? You sure? You just kind of perked up there for a second. Okay, just want to make sure. Well, what'd you get?
Wait, why was there one line C?
At least 1 means 1 minus none. Remember how I drew this before? I had 0, 1, 2, 3, 4, all the way up to 100. I want at least 1. So if you remember, the binomial only does less than. So to find that, I'm going to subtract that from 0, or from 1. Okay? Does that make sense, sort of? Just remember, at least 1 is always 1 minus none. Yes? 0.0025. There's an extra 0 in there. See how it has 3 zeros? This has 1. Oh, here. Oh.
I got A.
It's not A, it's B. That is so, they will not do that to you. This, again, these questions are written by Barron's, right? Shirley's question is this. Those are so close, right? I mean, that's just ridiculous, kind of, in my opinion. I don't think they would give you something that close on the exam. But the more accurate answer is B, okay? But I really don't think they would do that to you. At least I hope not. Again, these are written by Barron's, not ETS. So these are not written by the actual writers. These are just people who get paid to write alike questions. Okay? Yes, ma'am. Yes. Yes, that's fine. Yeah. Mm-hmm. Oh, yeah. Yeah. All right, here we go. Next question. Is this one that you could read, by the way, their contingency table?
Yes.
Okay, that one was okay? All right. I will look at it now if you don't have it written so that you can see what numbers go in there. Because I realize that once we get to these contingency tables, the numbers become difficult to read. If you have, it's not a contingency, sorry, this is a probability distribution. If you have a table with probabilities like this, what is a quick way to get the answer that will work every time? Just put them in your stat list 1, stat list 2, and then do your 1 var stats. Let's remind ourselves how to do that, okay? If we want to find the mean and standard deviation, and we have a table like this, we have a probability distribution, we can simply go and, we can go and enter, okay, there we go. We can go to stat and edit, and we can enter our numbers, 0, 1,000, 10,000. And then we can put the probability of each in list 2, 0.6, 0.3, and 0.1. Okay, what happened? Not paying attention? 0.6, there we go. 0.3 and 0.1. By the way, what should all those probabilities add up to be? 1, and they do, so we know we're in business, okay? I'm going to go to stat, calc, 1 var stats, but I have to put this in the calculator, don't forget. List 1, but what is the frequency list? List 2, because that's where I put all of the probabilities of each of those events occurring, and then we'll calculate. Oh, I did too fast. Okay. So the mean was 1,300. Again, the standard deviation that we have to use in this case is the population one, which is the 2,934. So answer choice A looks like the best answer here. Okay. To me, on a multiple choice question, that is the easiest way to save time. Okay. We can go how to do it by hand if you're interested. Just to remind us, in case you have something else that comes up that's worded differently. How do I find the mean again? By hand. 0 times 0.6 plus 1,000 times 0.3 plus 1,000 times 0.1. That would also give you the same answer. Takes a little longer, not a big deal. Standard deviation, do you remember how to do it here?
No.
Okay, you take the value minus the mean, square it, and multiply it times the probability. Add it to the value minus the mean, square it, times the probability. Add it to, and then the square root of all that. No. Now, I say that, kind of like they're not going to ask you to graph, and it's on the first thing of the test, right? Or the practice exam. Really, that's no. The point of an exam is to make sure you understand what that's not something that they would hopefully ever ask you to do. But just process-wise, do we know how to do it with the table? Worst case scenario, okay? All right, next question. Let's look at this one. What are some key words in this problem? Independent is a key one, for sure. Independent means that we're not dealing with conditional probabilities, right? Where do you see that? It's in there, independent. So we know we're not dealing with conditional, okay? That's a key word. That eliminates some choices for us. What's another key word? Both. Okay? So both means one and another. The word and means I do what operation? Add or multiply? Multiplies, that's all you're doing. And since they're independent, you can just straight multiply them. And that's it. So we have 6,000 high students, 18 prefer basketball. So we have 1,800 out of 6,000 prefer basketball. And that number was 0.3. Okay? And then the other situation is honors courses. We have 1,500 of those. So we have 1,500 honors courses, which was 0.25. So we want to figure out how many students both take honors and prefer basketball. So it's just a matter of multiplying them together, 0.3 times 0.25. And hopefully you guys got 0.075 here. And since it said how many, how do I go back and use that probability? Multiply that times the 6,000. And when I do that, I get 450. How are we doing? Good? Jasmine's rocking it so far? Got them all right? Come on now. My little track star. All right, good. All right, here we go. So again, when we're looking at probability questions, I want us to identify keywords in the problem because those keywords really guide us. Is it a binomial situation? Is it a tree diagram situation? Is it a Venn diagram situation? Just like what we saw with independent, am I just using the straight multiplication rule? Okay? I don't know. So look for those keywords to guide us here. Tell me what you think you should do here. I think it's a conditional probability too. Okay? I see the word both, and sometimes the word both means that you want to look at a Venn diagram. Both just means that you're looking at one and the other can happen. So both really means the probability of A and B. That's what that means. And in the previous problem, the probability of A and B was just straight multiplying them because they were independent events. Okay? But here we have a different situation. So let's write down some information that we do know. The probability of a major plague is 39%. Okay, so let's just call it probability of P. P for plague and famine. So we have the probability of plague is 0.39. We have the probability of famine is 0.52. And the probability of both plague and famine is 0.15. What is the probability of a famine given that there is plague? When I see the words given that, that is definitely a clue that it is conditional, right? Given that is your key there. So I pulled out the key information. Let's see if we remember how to do. Look at your formula sheet. If I want to say, what's the probability of famine given that there is plague, what am I going to do? Probability of famine and plague, or plague and famine, either way, divided by probability of the plague in this case. Do I have all the information that I need? I don't have to find it. There's no missing information. Sometimes there is. When there's missing information, we want to look at the tree diagram to help us find that. But nothing's missing, so we're good. So we can say the probability of 0.15 on the top, and then we have 0.39 at the bottom. And so that, to me, I got to be D. How'd y'all do? So again, sometimes you're missing some information, so that's when the tree diagram will help us. But here we were given everything. Yes, love? Yes, you may. Bring the past, though, because they get all kinds of crazy, with which they should, about being in the hallway. All right. I see another key word in this problem. What do you see? Independent. But it's asking you if they are independent. Okay? So there are several different things we can do to answer that question. Are they independent, yes or no? Well, look at some of the answers. You what? Me too. Okay. So we're looking to see. Let's write it down what we know here. So it says that retrospectively, 0.4 is stock market decline. Probability that the hemlines are lower is 0.35, and that the both events is 0.3. Yes, sir.
Even if you didn't know you're independent, you can look at the answer first to eliminate one.
Sure. What could you eliminate right away?
When you're looking for independence, you're looking for what's equal, so you know it's not A, because it's saying something is not equal.
Right. That's true. If you remember that. So what he's saying, he's exactly right. These two contradict each other, I think is what you're saying, right? Yes and not equal. It should be yes because they're equal, or no because they're not equal. So that's what he's saying. So we could also eliminate that for the same reason. And then I have no idea what C is even saying, right? So I've already eliminated a lot. So I'm now I'm at 50-50. The answer is B for that reason. Okay. Great idea, though. Eliminate what you can. I totally agree.
The answer's never like, when it's like worded like easy, it's usually never like, because like.
It has come up. I hate to say, I think one of these is actually a no, not above actually. So never, but yes, rarely. Like if you're stuck between that and another one, probably, and you're just not sure, I wouldn't pick that one. I agree with you. But it does happen, but it's not very often. All right, next question you probably couldn't read. Could you? Oh, that one wasn't the bad one? All right, sorry. So this we're trying to figure out to answer it. This is like a free response kind of a question. So we have to figure out what to do. How do I answer part A? Yeah. This is like the expected value or the mean. Okay? So it's literally just finding the mean. You could type it into your stat like we did, the list like we did on our calculator a second ago, or you can just say 0 times 0 plus 1 times 0 plus 2 times 5 plus 3 times 36, etc. And you should get 500. Okay? Part B, what is the probability? Now that one you probably can't read. Oh, it's the same table. You're right. You good. All right. How many total number of hospitals did I have? Why is that important? That's the total sample size of what we're looking for, right? So it says, what's the probability that a patient will have a positive response? So I need to figure out how many total patients I have. So the number of total patients, how many hospitals were there? Oh, oh, sorry, hang on. How many patients did I have? So that was the question. Okay, so that was the question. I was like, where did the 6 come from? All right, so we have 6 patients. Sorry, that was important, right? So we have 6 times 125 gives us the number of patients, right? And so that was 750. So to find the probability, it's just 125 out of 750. No, I'm a liar. It's not. It's 500 out of 750. I apologize. Thank you. The 500 we found is in part A. And that was 0.6 repeating. 0.67. I want to do it that way. Okay. Now, the next one, a little bit more difficulty. Okay? It says, what is the binomial probability distribution with this probability and with n equals 6? So we have to figure out the probability of 0, the probability of 1, probability of 2, the probability of 3, probability of 4, probability of 5, and probability of 6. It does say that, so we know we're going to have to use that, right? We could do binom PDF. I'm sorry, yeah, PDF, because it's exactly 0, exactly 1, exactly 2. Or you can use the calculator, either one. Probability of 0, I'm just going to do 1 for you so you can see. Let me get to one where, well, that's fine. Probability of 0. What would that look like? It's going to be 6 choose 0 times 0.6 repeating to the 0 power, and then 1 minus that, or I'll just say 1 minus that, to the 6th power. And you get 0.001. Where did I lose you, Kyle? You had a weird look on your face. And you could do PDF. I'm fine with that. Binom PDF. Would you prefer that? I kind of would. Where'd my calculator go? There it is. It wasn't. All right, so if we do this on the calculator, we could do binom PDF, which would be totally fine. There we go. And we're going to have 6 trials. We're picking a probability as 0.6 repeating. The x value in this case is 0. We're going to paste, and we should get 0.001, just like I showed you. Okay? Rule of thumb, 3 decimal places is a good rule of thumb to round to. Okay? So I'm going to say 0.001 here. And then I could just literally, if I wanted to kind of find the probabilities fairly quickly, I could go ahead and do the same exact thing, except for change sugar. There we go. Change the last number to in each case. So change it to a 1, I get 0.016. Change it to a 2, and I'll just write them down. I get 0.082. I get 0.219, 0.330, 0.264, and 0.088. What should all these probabilities add to? 1. So if you're ever asked to complete a probability distribution, check that. Okay? Make sure it adds to 1. All right, the last question says, what's the expected number of hospitals reporting each number of positive responses? That would simply be 0 times the probability, plus 1 times the probability, plus, and so forth. The answer I got, for each case, so I'll just make another table. Let's go. So the expected number of 0, I got to be, Oh, I'm sorry. That's not what you do at all. I told you wrong. Sorry. It's the number of positive responses. So you know you're going to have 0 through 6, right? And then you're looking for the expected number of positives. So what you're going to do is you're going to take the probability you just found, so 0.001 for this case, and you're going to multiply it times the 125 hospitals. And so I got 0.125 here. So the next probability is 0.016. Multiply that by the number of hospitals. And you got 2. And so forth. It says each, right?
Is it 4?
The next one? I got 10.25. I'll write the answers. So I have 10.25 here. I had 23.375 here. I had 41.25 here, 33, and 11. That's what I got. Okay. All right. Let's go ahead. Do the actual and expected seem to be close? Well, if you just compare them, you could do the chi-squared goodness of fit, and you would see that they do differ. But that's for a next question. That's for a next unit. All right, let's get back to multiple choice. Okay, because that's where we, I think, are suffering. And isn't this lovely that the question is gone? There it is. Okay. All right. Contingency table. Do you guys need me to write the numbers? Can you see them? I think the same thing happens to be on another page. Let me see if I can just quickly make it bigger so you could see it. All right, so I've made it larger here. So it says we want to, what's a key word in the problem, by the way? All right, and, don't I see an and? Oh, no, this is the wrong problem. I'm on the wrong one. So we have, given that he has skipped many classes, when we have a contingency table, that means that that's a conditional probabilities that adjusts what we're dividing by. So if I was asked to show work in this case, we have a student has under a 2.0 GPA, given that he has skipped many classes. So we're looking at skip many classes. So 80 divided by what? All right, let's write it out if you're not sure. So we want the probability that they have under a 2.0, given that they have skipped classes. So that is the probability of under a 2.0 and skipped classes divided by the probability that they skipped classes. So isn't it 80 divided by 110? Right? So isn't that just 0.727? Given that is what you divide by, if that helps. That's the total that you divide by. Are we good? Okay. Which of the following are true statements? These are all out of order. Is that the next one you guys have?
Yes.
It's not the next one I have. Very strange, but I don't care. Is an event always at least 0 and at most 1? Yes. So that's true. The probability that an event will happen is always 1 minus the probability that it won't happen. True. That's a complement. If 2 events cannot occur simultaneously, the probability that at least one event will occur is the sum of the respective probabilities of 2 events. Someone say that in English or in math. Devin, explain it to us in math. Which means that the Venn diagram would look like this, which means that, give me a stats word that means. They are mutually exclusive. Keep going. They're disjoint, yep.
Probability that an event will occur is the sum of the respective. So the sum of the two probabilities is the probability that of one of them.
So if we call this 1 and 2, the probability that 2 occurs is equal to the probability of 1 plus the probability of 2, which doesn't make any sense. It doesn't say that. So just because they're disjoint doesn't mean you add them together to get, so that makes no sense, right? So what do you think that is? Would you agree with that? All right. Sometimes, basically, cannot occur simultaneously. I want you to pull out of that. That means mutually exclusive or disjoint. We know what that means. All right. We're back to this question. So what is the probability that a student has a GPA under 2.0 and has skipped many classes? Well, isn't that just 80 divided by the total? What was the total? 1,000. So 80 divided by 1,000. And you got...
Yeah, it doesn't always add up to about a one-sided.
Oh, is that what you were saying? They should add. That is a problem. They should add to be 1,000 in either case. But I don't have.
It's not 2.5, it's 255 on the...
Yes. Is that correct? Is 80 plus 175 255? Okay. So I just added wrong or typed wrong or had fat fingers or something. I don't know. Okay. So thank you. But please make that adjustment on yours, please, and I will do that on mine as well. Okay. So is it 0.08, right? Right? Okay. Just making sure. All right. So now we're looking at, are they independent? Somewhere on the exam, this is going to come up. Okay? Somewhere. So let's see if we can answer this question. Maybe we can use what Isaiah said and rule out some of our answer choices because, well, no and not equals happens 3 times. So unfortunately, we can't use that here. Okay? Where are they getting these numbers from?
Probability of GPA out of the total number. GPA to.
Let's put it in context for a second. So we are looking at trying to find the probability. If we're trying to show independent, we can show it this way. Less than 2.0 and skipped is the same as less than 2.0 times the probability of skip. If that equals each other, then they are independent. Would you agree? Okay. So let's see if those numbers are where they're coming from, because that is one way to show independent. The other is to show that the conditional equals the real. Okay. So, or not the real. They're all real, but the conditional equals the non-conditional. So let's see which one they're asking for here. So 2 and is 80 divided by 1,000, right? Does that number show up here? So that's not what they're using. Would you agree? Okay. So what's the other way to show conditional? I'll write it in blue. So we tried that. We're hoping that just straight multiplication rule would be enough. It's not. The other way to show independence is the conditional. So the probability of less than 2, given that they skipped, is equal to the probability of less than 2 and skip divided by the probability of skip. You think that's the rule, right? We want to say, does that equal the probability of just less than 2? We want the conditional probability to equal the non-conditional probability.
You just wrote the probability of less than 2 given that they skip equal, like...
The middle is just the definition. So you can skip that part altogether if you want. Yes, sir. It says, does it say between 2 and 3? Oh, thank you. I'll just change that in each of these cases. Thank you. Okay, Isaiah. Always divide by the second one. It's always divide by the second one in a conditional probability. Okay. For independence, what you're trying to skip that part for a minute. All you're trying to do is trying to show that the conditional equals the traditional. The conditional equals the traditional. I don't know. I don't know what to call that. Just it's the non-conditional probability. You're trying to show that the probability of A given B equals the probability of A. Period. Okay, I'm just writing it in context, that's all. I'm trying to show this. Okay? So maybe that's where the numbers are coming from, I don't know. I think that is where they're coming from. So what's the probability that they have between a 2 and a 3 GPA? What would that be? That would be 25 divided by 1,000? Do you agree? No, not 25. 475 divided by 1,000, right? So that would be 0.475. And that's some of the numbers that are showing up, isn't it? So we know we're on the right track with this question. Okay? So now we have to say, does that equal the conditional? Okay? So what is the conditional? Well, between 2 and 3, given that they skipped. Between 2 and 3, given that they skipped. So it's 25 divided by 110? Is that right? What is that? That doesn't look right. Is it skipped few? Oh, good Lord. Skipped few is that. Do you agree with that part? So 450 divided by 890. I don't know what that number is. I don't know what it is. Help me out. Woo, look at that. That's the other number that showed up, right? So we know we're on the right track. They definitely don't equal each other. Therefore, the answer is A. I did. 450 divided by 890. Given that they skipped few classes, so I'm dividing by they skipped few classes.
That's conditional. Yeah, we're doing independence. But I thought the over 1,000 came from that equal.
It does. Yeah. When you have a conditional probability, you look at the and, which in this case is the 450, and I divide it by the probability. It's 450 over, they're the same. It's 450 over 1,000 versus 890 over 1,000. The divided by 1,000 cancels out in both cases. So it's just 450 divided by 890. I'm not sure where I lost you. It's the same thing we just did. Why am I unclear today? Where did I lose you?
Okay, on the top it's like, okay, it's like the probability is 2 and 3 and
that's where the 450 came from. Divided by skip few classes. So that's why you're dividing by 890. You divide by that total. Shaken. Chill moose. Moose? Chill mood? What does your shirt say? Oh, I thought I said moose. I'm like, why are we moosing? I don't get it. Okay. Next question. All right. How much time do we have? About 15 minutes. All right. We can do it. I need to get through probability is what we need to do. This is a great one. If this one takes 15 minutes, that's fine. This is actually a good one to look at. Who said tree diagram? Why? Because that's what you did and that's what you should have done. Okay? So those of us who didn't do a tree diagram and just kind of circled answers, no mention of any names, Hunter LeClaire. I wasn't looking. I wasn't talking to you. I'm looking at you, Chill Moose, but I'm talking about Hunter. Okay? This required some work. I didn't see that work on a lot of your papers. This is a tree diagram problem. Why? There's more than one outcome. It's a multi-stage probability, right? So I know for a fact I have to draw a tree diagram. Because so few of you did it, I'm going to pause for a minute. I want you to do it. And I'm going to randomly pick one of you to draw it on the board for me. Go ahead. Why do you think we've broken it up that way, by the way? Because almost all colleges give you a credit for 4 or 5. Some give you a college credit for a 3, and none give you a college credit for a 1 or a 2. So that's kind of why we've broken it up. Does Lander take it? A 3? Woohoo! And where are you getting these numbers from?
It said, you got 4 or 5 or 50% students per page.
The percentages were just given to us. Good? You're good. Keep going. Okay?
And then we see whether they receive college credit or not. So now we would see if they have college credit.
Sure. Okay? Okay?
And then it says that 0.95 people, 95%, receive college credit if they score 4 or 5. So the
Complement?
complement would be.
Because each of the branches of the tree have to add to be 1, right? Okay? I agree so far. Multi-stage probability. I like that you change colors. It makes it easier to see a little bit. Sort of. Yeah, CC is college credit, and then the other one would be not college credit. Do you need to go to the bathroom? No? Okay, that's what you need to. Help yourself. All right, keep going. Shh. Yep. When you multiply across the tree, what probabilities are you actually finding? So, but one and the other. So that would be the probability of getting a 4 or 5 and getting college credit, or the probability of getting a 4 or 5 and not getting college credit. Yes. I don't know what you did.
Like I did what he did.
You just.
But then I tried to do the final step.
Oh, we're going to get to the final step in a minute. You have to add some things for the final step. Yeah. Shh. Listen.
If a student is choosing at random from among those taking the exam and receive college credit, so the given is that they receive college credit.
So let's make it so we can have some more room. So yeah, let's extend our page real quick. All right. Perfect. So far, he's done the tree diagram exactly how you should have been doing the tree diagram. I agree. And he's circling 3 things for a reason. Those 3 probabilities have to do with the fact that they actually got college credit. And he had to add all of those together. Okay? Because that's the given that. I'm going to write it in context here. Actually, we can write it at the same time. Look at how fancy we are. So what he's doing is finding the probability of, oh, you're done? I didn't mean to run you off. That's all right. Yes, I do. So given that were given college credit, go ahead, you just have to use one of those 2 colors. Zip it up. All right, so the answer was B. What is the probability that they received a 3 on the exam given that they received college credit? So the probability of 3 on the exam, where'd the 0.125 come from? Because that was 3 and college credit, right? So that's where we have this one divided by probability of college credit, which is the sum of the three things that were circled.
The reason I was asking .06, so that's what messed me up.
Oh, bummer. Pay attention to those zeros, right? All right, the bell's getting ready to ring. We did not get through the last few, but at least let me give you the answers to them. So you have those there. And then I'm going to give you theme 4. It will be due next class. Okay, so we have C, we have D, we have B. These will be online. C, D, B, B is the last one. So the answers went in order C, D, B, B for the last topic, okay? Your homework is going to be theme 4, so let me go ahead and give that to you. So since I don't have the theme 4 copied, it's on, theme 4 was supposed to be for inference. One of the things I want to talk about next class are the type of errors, because Devin asked me a question about type 1 and type 2 errors. So I will address that in class next Tuesday. But you are given this practice exam from 2012. It's a release practice exam. Go ahead and work on that. Multiple choice is what I will be grading for homework credit. I'd like for you to attempt the free response as well so we can discuss it, but I won't grade it for a grade, if that makes sense. The whole multiple choice. I would like for you to give yourself an hour and a half and time yourself and treat this as a true practice exam, okay?